Good morning, everyone. Let us discuss today about internal fixators. These will be the contents. Let us look at it. Definition: a surgical procedure that stabilizes and joins the ends of fractured bones by internally placed mechanical devices such as metal plates, pins, rods, wires, etc. are known as internal fixators. After operation or after surgery, to fix the fractured bone, we internally fix something which joins the fracture ends together. Those are known as internal fixators. Internal fixators can be classified as pins, wire fixation, screw fixation, plate and screw fixation, and IM nailing or intramedullary nailing. Lambert's principle of surgical treatment of fracture. This is very important to classify whether a surgeon wants to apply internal fixation or external fixation for a fracture. What are the Lambert's principle are? Anatomical reduction, stable internal fixation, preservation of blood supply, to pain-free mobilization of adjacent muscles and joints. Anatomical reduction. After a dislocation of fracture, whether close reduction and conservative method will help or a open reduction is needed. In open reduction, again there are two types, internal fixation and external fixation. Stable internal fixation. Whether a fracture after dislocation or a fracture, comminuted fracture, will it be stable after internal fixation? If there are many parts, or imagine a bone is after fracture is separated like about 10 centimeter tibia, middle shaft fracture. After fracture, it's separated about 10 centimeter. Will the internal fixation stabilize the bone? No, obviously not. So in that case, we choose external fixator. Preservation of blood supply. Internal fixator definitely preserves a lot of blood supply compared to external fixator. Active pain-free mobilization of adjacent muscles and joints. In internal fixator and external fixator, after the surgery, the movement should be active and pain-free. This is very important and this can be decided collectively by surgeon and physiotherapist. Biomaterials used for fracture stabilization. These are the various biomaterials used for fracture stabilization. Metals 316 stainless steel, iron, chromium, nickel, titanium, aluminum, vanadium alloys. Initially, when this was invented, titanium 316 stainless steel was used. But nowadays, titanium, aluminum, vanadium alloys are more frequently used because they are more acceptable by the human body. Commercial pure titanium and tantalum. Tantalum is a part of titanium only. Bioabsorbable materials. Polyglycolic acid, PGA, very important. Vicryl, again very important. Polydioxanone and PLLA and poly D-L-lactic acid, PDLLA. If you remember, TKR and THR, bioabsorbable material, are frequently used over there. Indications for absorbable fixation devices. What are the indications for these? Metatarsal osteotomies, definitely important. Metacarpal metatarsal fusions, to fuse beneath something. Malleolar fracture, because they are very small fracture, they will not heal because you are continuously, constantly weight bearing. So definitely yes, malleolar fracture again a part of can be a part of avulsion fracture where we can use screw fixation. Osteochondritis dissecans, yes. Fractures of radius and olecranon. Yeah, internal fixation is commonly used rather than external fixation for radius and olecranon. Epiphyseal fracture, Steinman pin, part of internal fixation. It can be used over here, epiphyseal fractures. Ruptures of ulnar collateral ligament of thumb. Methods of applying. Exposure of the fracture. Yes, cut open the fracture, expose it. Reduction of the fracture, open reduction, definitely done in ORIF, open reduction and fixation. Provisional stabilization of fracture and definitive stabilization of fracture. Coming down to types of internal fixator. Before we jump into the screw and nail, let us understand screw anatomy. As you can see in the first slide, look at that screw anatomy. This is the screw what we are going to place. Okay, the screw has root diameter. You can see that. See, root diameter, the threads, the leads are spiral and tangential. They are not horizontal to each other. They are tangential to each other. The pitch The design of the thread, you can see that there are two types of thread, V thread, buttress thread. This image is taken from Maheshwari, Orthopedic Maheshwari. You can refer the same book. And the last part is taped thread. This taped thread is sharp enough to, drill inside the bone. Okay. So, screw anatomy, this is very important because inner diameter, only the shaft without the thread. These are the threads, only the shaft, outer diameter with the threads. The two diameters are very important because the outer diameter is nothing but you have to drill a hole in the bone so that on the basis of the outer diameter, not the inner diameter. That means you are including the threads and the screw itself. The pitch angle between the threads. The the tangential threads, that is the design of the thread, you can see that V thread and buttress thread. The angle between these two threads is pitch. The pitch is not the pitch. The design of the thread is such that you can the blood supply and the bones can osteoblast can reproduce itself so that the healing takes place quickly. Lead and threads, the final part. Screw fixation. How do we fix the screw in a fracture? There are various types of screw fixation: machine screws, ASFI screws. Machine screws, whole length threaded, can be self-tapping, used primarily to fasten hip compression screw device to shaft of femur. Let us understand only one or two whole length threaded and can be self-tapping. Now in whole length threaded, the entire length is threaded, whereas can be self-tapping, it's just one part, small part is threaded, it's just fixed on the bone and is been hit on behind of the screw. That is known as self-tapping screw. Plate and screw fixation, where plate and screw are used together. This type of fixation converts tensile forces to compression forces on the convex side of the eccentrically loaded bone. So whenever there's a fracture, tensile is nothing but it's just pulling away. We need to avoid the tensile forces on the fractured bone to enhance the bone production in order to heal the fracture. So thus plate and screw fixation is very important to convert the tensile forces into the compressive forces. Also, let it be osteoporotic bone or let it be a fracture. Weight bearing enhances osteoblast production, thus lead to healing. So thus compression force cannot be nullified, whereas tensile force must be definitely reduced. Tension band across the fracture on the tension side of a bone. You can see that there's a tension band across the fracture on the tension side of the bone. Main functions of the plate in plate and screw fixation is internal splinting of the bone. Yes, splinting is nothing but just holding up everything. So thus internal splinting of the bone in the aligned manner. Follow principle, that is the bone protects the plate. Here the plate is not protecting bone. You can see that the bone is protecting the plate. If you place it here, definitely the plate has to protect the bone, which is going to be impossible because the plate's size is very small. So thus plate and screw fixation always follows bone is protecting the plate, not the other way around. In the fourth slide, you can see that intramedullary nail fixation, very important. IM nail fixation. Satisfactory stabilization of fracture by IM nail intramedullary fixation is possible under following circumstances only. Non-comminuted fracture, unlocked nails. Locked medullary nailing technique should allow nailing of fracture to within 2 to 4 meter of the joint. The type of nail and degree of reaming varies with curvature of the bone. There are two types of IM nailing, centromedullary and condylocephalic. Types of IM nailing fixation, as we had explained in the previous slide, that is static, dynamic, and double locked. Static is very important in order to progress and enhance the healing in a stable, aligned manner, whereas dynamic, no rotatory force is restricted here, it's just locked on one side. So, as these are the types of internal fixation. I hope you understood. Any doubts, you can contact on the mail or you can drop the comment box. Thank you.